is glad to join the workshop Parity Violation from Home. My name is Lu Yin. I'm working in Korea, APCDP. And today I will introduce my research is Cosmic Birefringence model dependence. This paper is cooperated with Zhou Tuhin, Professor Bohong Li, and this paper just be accepted by GCAP yesterday. And I will introduce my research. In optics, the rotating angle of photon, the linear polarization of photon will have a rotating of the plane, and this is a very common phenomena in nature. In our universe, people have the most accurate observation technique that is on photon. From the discovery of CMB, people already realized is there possible for this kind of rotating also happened in the photon from CMB time and have the rotating during its spread to Earth. This kind of research is named as Cosmic Birefringence. At past, because of the limit of the technique, people only can get the rotating angle beta is under 1 degree. But this new paper, Komatsu's new paper, told us that this rotating angle may be 0.34 degree, and the confidence is larger than 3.6 sigma. We are trying to give the explanation of this result, this rotating angle from theoretical. Okay, the cosmic birefringence is very important in theoretical physics. It's not only is a new phenomenon, but also is evidence of parity violation, and it can give us new physics beyond the standard model. One of the explanations is to use axion field coupled to a photon when the Chern-Simons term. And this theta is the axion-like field. And the F mu theta is the electromagnetic tensor of the photons. The G is the Chern-Simons term and can be considered as a constant number. Our work will also give a fitting result for the number of G in the next we will introduce later. And this axion can be considered as dark matter or dark energy, which act as a birefringence material present in our universe. Okay, this is a Lagrangian we gave before. The parity violation we mentioned is through the F mu theta term, because this produces a parity odd and gave a special minus signal, a seg here. With this new term, the equation of motion will be modified with this additional term. Contributed by the Chern-Simons coupling, the different phase velocity of right-hand side and left-hand side is this term different, which is the new polarization. With this new polarization, the rotating angle beta here can be defined in this form. With this rotating angle beta, the number of CMB E and B mode will also be modified. From this figure, the E0 and B0 is the present observation results, and the EL and BL is the moment of CMB in the early universe, especially the cross power spectrum here will also be modified by this rotating angle beta, especially this EB is generated by difference between EE and the BB spectrum. If beta is equal to 0, the CLEB will also back to 0. The EB power spectrum will back to 0. So the EB power spectrum is aimed to test the rotating angle beta. This is the present observational results. This is a T mode, E mode, and B mode. Present observation of EB power spectrum. This is for the high frequency of Planck. And this is the EB power spectrum from Planck's paper. We can see it is highly non-zero, not only back to 0. That is the first evidence for the beta is non-zero. Okay, we have such evidence, and what's the accurate number of the rotating angle beta? Because from our observation, there is dependent by this rotating from the photon and the rotating of our detectors. So that is one problem we have. Previous, the first measurement of alpha plus beta is more than -6 degrees. With better measurement, there is a smaller number for the error and the rotating angle. Finally, this is our present result. We only consider the rotating angle beta for photon. There are already many observations. Okay, that is one important question. Is the cosmic birefringence model dependent or not? In order to test this, we consider three different pseudoscalar models to interaction with photons in CMB time. This pseudoscalar field can be considered as early dark energy, which is an additional dark energy compared the effect in standard lambda CDM. Okay. The first is the early dark energy model. It has this form of potential, and this is rock and roll model. This is alpha attractor model. This figure is the evolution of the energy density of every special pseudoscalar models. Especially this number is from the best fit of Planck plus BAO plus supernova result. For the early dark energy model, we select the n equal to 2 and n equal to 3. For the rock and roll model, we consider n equal to 2. And for the alpha attractor model, we also select the number of p equal to 2 and n equal to 0. Only in this selection, the alpha attractor model can be considered as pseudoscalar. This is the oscillation of the potential after it starts to decay. And the CMB time is around the 1100. That is still have the exist of these three early dark energy models. The rotating angle beta will start to have effect from the CMB time to present universe. This is our first result. Because we considered the EB power spectrum and considered the Chern-Simons coupling, the Boltzmann equation will also be modified by this special interaction. This is EE power spectrum, and this is EB power spectrum. We can see in the high L part, the EB power spectrum is much better for E power spectrum to distinguish the four kind of models. Okay, that's our first conclusion. EB power spectrum is an important smoking gun for different early dark energy models that is beyond the current EE spectrum in high L part. Okay, we also considered the EB data from Planck 2018. This central point and error bar is get by ourselves from the Planck's original data. And we can see this is rock and roll model, and this is alpha attractor model. With this comparison from high L, we can also see the two model is very easy be different with the 0 point. 0 point is lambda CDM. And this is we consider G equal to 1. And in the second, we also do the best fit of G. That is the fitting result. Every model can suitable the current observation Planck 2018 very well. And this is the fitting result of the Chern-Simons term G. For lambda CDM, that will be equal to 0. For alpha attractor, is the best fit is 0.16, and rock and roll's best fit is 0.12. So the value of Chern-Simons term is model dependent, and the current data cannot distinguish the two models. And then we can also calculate the rotating angle beta with the best fit of G. The value of from the value of G is model dependent. We can also see the rotating angle beta. This is result for rock and roll model. The number is around 0.15 degree, and the best fit of alpha attractor is only 0.02 degree. We also remember the early dark energy model result is 0.34 degree. So the rotating angle beta is also heavily model dependent. This is a relationship between G and beta. So this is our conclusion. The cosmic birefringence is a remarkable parity violation effect, which is beyond the standard cosmological prediction. And recently, new breakthrough in CMB data analysis lead to a hint towards non-zero cosmic birefringence rotating angle. That's the beta is equal to 0.34 degree. We studied the EB mode of rock and roll and alpha attractor scalar field for the first time, and the value G is model dependent. Moreover, the rotating angle beta is also highly model dependent. The EB spectrum alone cannot distinguish the two models based on current data, but it's an important smoking gun for different early decade models beyond the current EE spectrum. That's all I want to introduce. Thank you very much.